Friends, let's look at equations of uniformly accelerated motion, the equations of motion. Now, we briefly, acceleration, which is the rate at which velocity changes with time, is defined as final velocity minus initial velocity over time. So, u v minus u will be, if you cross multiply, will be at. Now, v will be equal to u plus at. This is our first equation of motion. Okay. Now, we'll call that average speed, distance, because average speed multiplied by time. What this means is initial speed or final speed divided by 2, that is average. You add two numbers and divide by the frequency, the number. Okay. So you can call this the second equation of motion. Okay. Now if you look at this equation, you from equation 1, you can see that v equals u plus at. If you substitute u plus at for v in equation 2, would have, so wherever we see v in equation 2, we put u plus at. Of course, all will be divided by 2 and we are multiplying by t. Okay. Now, if you do the algebra, u plus u is 2u plus at divided by 2, we multiply by t. So this is something as, if you cross multiply, or okay, just leave it, don't cross multiply it. You have t is multiplying 2u plus at, all it means, and it's been divided by 2. So x, which is distance, is 2, t multiplying 2u will be 2ut plus t by 80 will be 80 squared. Now 2 is dividing both. That is something else. If I divide each of the times by 2 over 2, 2 cancels to half, s equals ut plus half 80 squared. Then this becomes equation number 3. Okay. This is kinetics. Kinetics is a branch of physics that deals with the study of the motion of body without involving the forces responsible for the motion. The converse is dynamics, which involves the force that causes the motion. Now, from equation 1, we can find out what t is. Okay, we can make t the subject of the formula from equation 1. So from equation 1, from v equals u plus at, t will be v minus u over a. Okay, so if we, I call it equation star, if we use equation star in equation 2, we use equation star in equation 2, we have s u plus v all over 2 times v minus u all over a. Okay, I can change this. This can be v plus u is something multiplying v minus u, and a is there. Okay. Okay. So I shift this a little for space. Okay. Now I have, what we have is S equals V plus U over 2, V minus U all over A. Here same thing as V plus U, V minus U all over 2A. That is S. Okay? So when we cross multiply, we have that S 2AS equals V plus U, V minus U. So this is difference of squares. If you expand this, we'll get V squared minus U squared. So this means U squared minus V squared minus U squared equals to AS V squared. This crosses becomes U squared plus 2AS. Okay? So this becomes our fourth equation of motion. So see, the first one is this, second one is this, third one, and the fourth one. Now we write out the equations we derived. See, the first one is V cos U plus 80, equation 1. Second one is distance is average speed divided by time, equation 2. The third one is S, that's distance displacement equals UT plus half 80 squared. From the equation 2. And finally, V squared equals U squared plus 2AS. That comes our equation 4. Now, if you look at this equation, these four equations, actually in physics, in kinetics, literally we deal with the following parameters. We deal with what I call volts. V is final velocity or final speed. A is acceleration. U is initial velocity or initial speed. T is time. And S is distance or displacement. Okay. Now, if you look at these equations, now we have volts is a mnemonic that I use in remembering these things. Volts. If you look at this equation, you will see that equation 1 does not have S, displacement of distance. So when you are given a question to solve and you list out the parameters and what the parameters do not include distance, this is a question to use, a proper equation to use. Equation 2 does not have acceleration. So when you are given a question to solve and you list out the parameters and the parameters do not contain acceleration, equation 2 is one to use. Equation 3 does not contain V. So when you are given a question to solve, you list out the parameters and V is not there, equation 3 is appropriate for the problem. Now, question 4 does not have T. So once you list out the parameters, having been given a problem and you can't find T there, this is equation 2. Let's solve a problem to illustrate this. Okay. Hope you can see it very well. Okay. Okay. Two questions. Question number 1 and 2. Okay. 1 and 2. Now, one says a body starts with jump question. A body starts from rest. Accelerates uniformly at 5 meters per second square. That is acceleration. Until it attains a velocity of 25 meters per second. Calculate the time taken to attain this speed. Now, solution. The question number 1. We list out the parameters. Once the body starts from rest, initial velocity is 0. Okay. Now, accelerates uniformly at 5 meters per second. So V A is 5 meters per second squared, 1 meter per second, meters second squared, or we call meter per second. And final velocity V says it attains a velocity of 25 meters per second. Calculate the time taken T. You can see this question, watch carefully. This of volts. V is U is always there. It has A, it has V, it has T, but it doesn't have S. So the appropriate equation to use is the first equation. It doesn't have S. And so we'll use V equals U plus 80. So V is 25 equals U is 0 plus A 5 times what? Time. Time is the one we are required to calculate. And so that will be 25 equals 5t. T becomes 25 over 5 equals 5 seconds. 5 seconds. 5 seconds. Okay. Now, this in the same vein, if we so here now t equals 5 seconds. Okay. Now, okay. Question number 2. Solution to question number 2. Number 2. What it says, I hope you can see it. That a body accelerates uniformly from rest. So U equals 0 at the rate of 3 meters per second squared. So acceleration is 3 meters per second squared for 8 seconds. T equals 8 seconds. Calculate the distance S. Okay. Write volts. So V is contained. U is always there. If you can see all the the 4 equations have U in them. This is first equation has, second equation has U, third has U, and the fifth equation, what is it? The equation, yes. The fifth equation also has, the fourth equation also has U. They all have the initial velocity, of course. That's reasonable. Okay, now we have U is here, as usual, A is here, this is 3, T is here. We are asked to calculate S. The S is here. What is not here is V. So we look for the equation that does not contain V. That equation is S equals UT plus half AT squared. Okay? But by the demand of this question, U is 0. See that because the body starts from rest. 0 plus half. Acceleration is 3 times T. T is 8 squared. So this T, so it's 8 seconds. T squared is 8 squared. So it's 64 times 3 all over 2, which is 32 times 3. This 3 times 2 is 6. 3 times 3 is 9. So 96 meters. Okay. So this is how to go about it. Well, I will still solve some other problems on kinetics. God bless you.